This is Geometry Unit 8, Lesson 11 on the angle bisector theorem. Now, the angle bisector theorem, in similarity, it does a neat thing when you draw it in a triangle. So let's take a look at what happens. Given triangle ABC, point D is on BC such that AD is an angle bisector of triangle ABC. So this segment right here is an angle bisector of BAC. Now we want to prove that BD is to CD, the two pieces the bisector is drawn to, are in the same ratio as BA is to CA, as the two sides of the angle. So let's see if we can prove that's true. So what we need to do first of all is to draw a couple of auxiliary lines so that we can do this. So I'm going to draw a line L through C that is parallel to AD. So if I draw my line here, I'm going to go through C so that my line is parallel to AD. Now why can I do that? Well, anytime that you draw a line parallel to another line, it's got to go through a unique point. So through a point not on a line, a point not on a line, there is only one line parallel to the given line, because that line is unique. That's the only line that we could draw parallel to this line that goes through this point C right here. Now, the other thing I want to do is extend BA so that it intersects the line, line L that we were given, at point P. Now, why can I do that? Well, that's a segment. You can extend a segment any direction. So a line segment may be extended in any direction. You can make the line segment as long or as short as you need it to be. So a line segment may be extended in any direction. All right, so I have created basically the triangle PBC. So let's see if we can work with those triangles and figure out some information about the sides and that deal with the angle bisector. So first thing that we have here is we have BD to CD is equal to PA to BA, or BA to PA. So BD is to CD is BA is to PA. So if a line intersects two sides of a triangle and is parallel to the third side of the triangle, then. All right, so we have BD is to CD, BD is to CD as BA is to PA. Well, if this line is parallel to the third side, what does it do to these two sides right here? It divides them in proportion. We talked about that a couple lessons ago. So if a line intersects two sides of a triangle and is parallel to the third side of a triangle, then it divides the sides in proportion. So those two sides are in proportion. So we know that. All right, now my next given statement is that CPA, this angle right here, is congruent to angle DAB, which is this angle right here. Those two angles are congruent. Why are they congruent? Well, since AD and PC are parallel, aren't those corresponding angles? Yeah. If lines are parallel, corresponding angles are congruent. So we have one pair of angles congruent. Now, we have DAB and DAC angles are congruent. DAB is here, DAC is here. Well, wasn't that an angle bisector? AD an angle bisector? So aren't those angles congruent? Yeah. So an angle bisector divides an angle into two congruent angles. So we know that. All right, and then we have DAC is congruent to PCA. DAC is this angle right here, is congruent to PCA, which is this angle down there. What kind of angles are those? Well, they're alternate interior angles because those are parallel lines. If lines are parallel, alternate interior angles are congruent. So now we have a bunch of stuff about angles. Now look what we have here. Between 5 and 6, and then between 6 and 7. CPA is to DAB, is DAB is to DAC, and DAC is to PCA. Well, notice right here, this and this is the same. So couldn't we use the substitution postulate and say CPA is congruent to PCA? Yeah, you can use substitution or transitive. So using substitution on those three statements, 5, 6, and 7. So now we have that CPA is congruent to PCA. So CPA is this angle right here, and PCA is this angle right here. So what does that make this triangle right here? Well, that makes PA and CA an isosceles triangle, because aren't those base angles? Yeah, it does. So if two angles of a triangle are congruent, the sides opposite are congruent. Okay, so now we know that PA and CA are congruent. Well, notice back here we had PA here and CA as well. So if PA is congruent to CA, couldn't we just substitute that in here? Yeah, using substitution, we can plug that in and say that BD is to CD as BA is to CA. All right, so what have we just proved actually? What we have just proved is this. If AD is an angle bisector triangle ABC, then BD to CD, the ratio of these two right here, is equal to AB to AC. Now, it might make a little more sense this way. P1 is to P2. The two parts of the side that bisector is drawn to is equal to the ratio of the sides of the angle itself. So P1 is to P2 as S1 is to S2. These two pieces are in the same ratio as these two pieces when this is an angle bisector, when that angle is bisected. So that is the theorem for today. So let's try out and see how this works. Triangle ABC has sides of 8, 12, and 15. Point P is on BC, so that AP is an angle bisector of the triangle. Find the length of BP. All right, so we're looking for BP. I'm going to make BP X. I don't know what that is. All right, now since AP is an angle bisector, we want to use our formula. We want to use P1 is to P2. The parts of the side opposite the angle bisector is equal to the ratio of the sides of the angle bisector as well. So if P1 here is X, that's my BP, that means that's going to be X, is P1. What would P2 be? Well, it would be this piece right here. Well, that piece right there, if this whole piece is 15 and this part's X, this would have to be 15 minus X. So this would be P1, this would be P2. All right, now which one would be S1? Well, S1 is on the same side as P1, so this one would be S1, and this one would be S2. So S1 is 8, and S2 is 12. So all we have to do is cross multiply and solve. Now be careful, remember you have to distribute here. So this is 12 times X, or 12X, is equal to 8 times 15 minus X. All right, distribute. 12X is equal to 120 minus 8X. Okay, because you have to do 8 times 15 and 8 times X. Solve for X, add the 8X over here, you get 20X is equal to 120. Divide by 20, and X is equal to 6. So that means that BP is equal to 6. All right, so our theorem for today is when an angle is bisected, the segment that bisects the angle divides the side opposite the angle in proportion with the sides of the angle itself. So that is your theorem for today. That's the angle bisector theorem.